Hey everyone, I'm Yash, and along with my partner Georgia Kriebel, we programmed a concurrent shell that uses a pre-forked worker pool, and I'll show you the demonstration. Before we start, we're going to run make clean and make. Now, before we start with the demonstration, I have to do scaty erase caret question mark because the TCS machines do not recognize my delete key. Now, to start running, we can start running the shell by running /shell, and you can see shell is active with 3 workers. To show the overloading of the shell and the fact that it can run 3 concurrent processes, I'll write the following: sleep 9, sleep 9, sleep 9. And if I write ls-la, you can see that all workers are busy. Therefore, 3 concurrent workers are running at once. Let me wait for the program to finish its thing. And that is an example of the blocking that we've implemented in the program. And now let's do the piping. So let's say I want to find all the C files in the directory. I can do the following. As you can see, we get the protocol.h, shell.c, and worker.c. The shell natively parses the pipe symbol, allowing for the standard output of the left command to be routed directly into the input of the right command. Now, you can, towards the end, when you write the exit command, it will gracefully close all of the open file descriptors and wait for all the children to stop the process. So to actually understand the multiplexing, let's start in this file, shell.c. Now first we initialize the worker busy state array. And if you look further down here, if we cannot find a available worker, we print the all workers are busy command. And this allows us to safely reject any future 4th or 5th commands that come down the pipeline. Now to remain responsive during all this, we use the select system call within the while loop right here. We use fdset to set each output and telemetry pipes, and we only do it for currently busy workers to not overload the system. Now, let's go down here. Since the select blocks with a null timeout, whenever a worker writes its binary, we can check that by using fd is set right here. And that will re-wake up select and allow us to see which pipe was written to and print the exit status and all of this. Now, telemetry is sent through this struct, and the task itself is sent through the struct. Now, how does this all work? So let's check the worker C file. We have the parse command, which is pretty simple, but the execute manual pipeline is the important part. We check if we actually use the pipe command in our command, and if there is no pipe symbol, we use the generic dupe2 output file descriptors, and we parse the command directly via execvp. Next, if we use it, the pipe command, then we fork 2 children, and we write the output and input file descriptors respectively here. We close each file descriptor and perform a graceful exit. To get the actual data, we use our usage and get time of day to get the system CPU as well as the user CPU and real-time execution time. Then we close gracefully.